Silver is a chemical element with symbol Ag and atomic number 47. A soft, white, lustrous transition metal, it possesses the highest electrical conductivity, thermal conductivity and reflectivity of any metal. The metal occurs naturally in its pure, free form, as an alloy with gold and other metals, and in minerals such as argentite and chlorargyrite. Most silver is produced as a byproduct of copper, gold, lead, and zinc refining. Silver has long been valued as a precious metal. More abundant than gold, silver metal has in many pre-modern monetary systems functioned as coinable specie, sometimes even alongside gold. In addition, silver has numerous applications beyond currency, such as in solar panels, water filtration, jewelry and ornaments, high-value tableware and utensils, and also as an investment in the forms of coins and bullion. Silver is used industrially in electrical contacts and conductors, in specialized mirrors, window coatings and in catalysis of chemical reactions. Its compounds are used in photographic film and X-rays. Dilute silver nitrate solutions and other silver compounds are used as disinfectants and microbiocides, added to bandages and wound dressings, catheters and other medical instruments. Characteristics: silver is produced during certain types of supernova explosions by nucleosynthesis from lighter elements through the R process, a form of nuclear fusion that produces many elements heavier than iron, of which silver is one. Silver is a very ductile, malleable, univalent coinage metal, with a brilliant white metallic luster that can take a high degree of polish. Protected silver has higher optical reflectivity than aluminium at all wavelengths longer than 450 nanometers. At wavelengths shorter than 450 nanometers, silver's reflectivity is inferior to that of aluminium and drops to zero near 310 nanometers. The electrical conductivity of silver is the highest of all metals, even higher than copper, but it is not widely used for electrical purposes due to its much higher cost. An exception to this is in radio frequency engineering, particularly at VHF and higher frequencies, where silver plating is employed to improve electrical conductivity of parts and wires. Silver also has the lowest contact resistance of any metal. During World War II in the US, 13,540 tons were used in the electromagnets used for enriching uranium, mainly because of the wartime shortage of copper. Pure silver has the highest thermal conductivity of any metal, although those of the non-metal carbon in the form of diamond and superfluid helium-4 are higher. Silver halides are photosensitive and are remarkable for their ability to record a latent image that can later be developed chemically. Silver is stable in pure air and water, but tarnishes when it is exposed to air or water containing ozone or hydrogen sulfide, the latter forming a black layer of silver sulfide, which can be cleaned off with dilute hydrochloric acid. The most common oxidation state of silver is +1, the less common +2 compounds fluoride, AgF2, and the even less common +3. KAgF4, and even +4 compounds, K2AgF6, are also known. Isotopes. Naturally occurring silver is composed of two stable isotopes, 107 Ag and 109 Ag, with 107 Ag being slightly more abundant. Their almost equal abundance is rare in the periodic table. Silver's atomic weight is 107.8682 grams per mole. 28 radioisotopes have been characterized, the most stable being 105 Ag with a half-life of 41.29 days, 111 Ag with a half-life of 7.45 days, and 112 Ag with a half-life of 3.13 hours. This element has numerous metastates, the most stable being 108 mag, 110 mag and 106 mag. Isotopes of silver range in relative atomic mass from 93.943 to 126.936, the primary decay mode before the most abundant stable isotope, 107 Ag, is electron capture, and the primary mode after is beta decay. The primary decay products before 107 Ag palladium isotopes, and the primary products after are cadmium isotopes. The palladium isotope 107 Pd decays by beta emission to 107 Ag with a half-life of 6.5 million years. Iron meteorites are the only objects with a high enough palladium to silver ratio to yield measurable variations in 107 Ag abundance. Radiogenic 107 Ag was first discovered in the Santa Clara meteorite in 1978. The discoverer suggests the coalescence and differentiation of iron-cored small planets may have occurred 10 million years after a nucleosynthetic event. 107 PD 107 Ag correlations observed in bodies that have clearly been melted since the accretion of the Solar System must reflect the presence of unstable nuclides in the early Solar System. Compounds. Silver metal dissolves readily in nitric acid to produce silver nitrate, a transparent crystalline solid that is photosensitive and readily soluble in water. Silver nitrate is used as the starting point for the synthesis of many other silver compounds, as an antiseptic, and as a yellow stain for glass in stained glass. Silver metal does not react with sulfuric acid, which is used in jewelry making to clean and remove copper oxide firescale from silver articles after silver soldering or annealing. Silver reacts readily with sulfur or hydrogen sulfide H2S to produce silver sulfide, a dark-colored compound familiar as the tarnish on silver coins and other objects. Silver sulfide Ag2S also forms silver whiskers when silver electrical contacts are used in an atmosphere rich in hydrogen sulfide. 4 Ag plus O2 plus 2H2S2 Ag2S plus 2H2O. Silver chloride is precipitated from solutions of silver nitrate in the presence of chloride ions, and the other silver halides used in the manufacture of photographic emulsions are made in the same way, using bromide or iodide salts. Silver chloride is used in glass electrodes for pH testing and potentiometric measurement, and as a transparent cement for glass. Silver iodide has been used in attempts to seed clouds to produce rain. Silver halides are highly insoluble in aqueous solutions and are using gravimetric analytical methods. Silver oxide, produced when silver nitrate solutions are treated with a base, is used as a positive electrode in watch batteries. Silver carbonate is precipitated when silver nitrate is treated with sodium carbonate. 2 Ag-NO3 plus 2O minus Ag2O plus H2O plus 2NO3 minus 2 Ag-NO3 plus Na2CO3 Ag2CO3 plus 2 nano3 Silver fulminate, a powerful, touch-sensitive explosive used in percussion caps, is made by reaction of silver metal with nitric acid in the presence of ethanol. Other dangerously explosive silver compounds are silver azides formed by reaction of silver nitrate with sodium azide, and silver acetylide, formed when silver reacts with acetylene gas. Latent images formed in silver halide crystals are developed by treatment with alkaline solutions of reducing agents such as hydroquinone, methylphenol sulfate, or ascorbate, which reduce the exposed halide to silver metal. Alkaline solutions of silver nitrate can be reduced to silver metal by reducing sugars such as glucose, and this reaction is used to silver glass mirrors and the interior of glass Christmas ornaments. Silver halides are soluble in solutions of sodium thiosulfate, which is used as a photographic fixer, to remove excess silver halide from photographic emulsions after image development. Silver metal is attacked by strong oxidizers such as potassium permanganate and potassium dichromate, and in the presence of potassium bromide, these compounds are used in photography to bleach silver images, converting them to silver halides that can either be fixed with thiosulfate or redeveloped to intensify the original image. Silver forms cyanide complexes that are soluble in water in the presence of an excess of cyanide ions. Silver cyanide solutions are used in electroplating of silver. Although silver normally has oxidation state +1 in compounds, other oxidation states are known, such as +3 in AgF3, produced by the reaction of elemental silver or silver fluoride with krypton difluoride. Silver artifacts primarily undergo three forms of deterioration. Silver sulfide tarnish is the most common form of silver degradation. Fresh silver chloride is pale yellow-colored, becoming purplish on exposure to light and projects slightly from the surface of the artifact or coin. The precipitation of copper in ancient silver can be used to date artifacts.